Right, okay, well, good evening everybody. Thanks for coming out tonight. And I'm going to talk actually about a lot about eclipses generally, just to give you the idea of what the whole wonderful phenomenon is about. And although we won't see it, I am going to talk about totalities and stuff, because a talk about eclipses would not be complete without covering the totality. I'm just going to go into some things about Friday and how we do it all safely and where we go and all that sort of thing. So I'll cover all of that. We'll talk first of all about why this all happens. This is what happens. It just occasionally, it is the case that the sun, the moon and the earth get lined up in space completely, and what happens there is that the moon casts a shadow on the earth, and if you're actually in the right place at the right time, the sun is completely blotted out by the moon. We'll just have a little bit of a look at the geometry of that. Here's some interesting facts and figures that you can tell I'm of a certain age. I've done all this in miles. I'm just old enough to still do miles. The sun is, give or take a little bit, 93 million miles away from the Earth, and the moon is somewhere around about, depending on where it is in its orbit, about 240,000 miles away. When you actually do the sums, you find out that the sun is 400 times further away from the Earth than the moon. And here's the thing, the amazing coincidence that happens nowhere else in the solar system. The sun is also 400 times bigger than the moon. In fact, it's 400.4 times bigger. But because the Earth's orbit around the sun is somewhat eccentric, and the moon's orbit around the Earth is even more eccentric, these things vary quite a bit. And sometimes, what's being explained in this short diagram here is that that's the variation in the apparent size of the sun. We're looking at arc minutes here. The moon varies a lot more, and when the moon is quite small, relatively, it won't actually cover the sun completely. So that means that actually most eclipses, most solar eclipses, are not total. They are actually annular, more annular than our total. To see a totality, not only does it have to be one of the special eclipses, where the moon is sufficiently big to cover the whole sun, but also you have to be in the right place, and that's the tricky bit. Let's have a little look here. The other point to just bear in mind about the geometry of all this is that the orbit of the moon around the Earth is inclined by about 5 degrees or so. So we do not, unfortunately, get a solar eclipse every month, which would be a nice thing to have, perhaps, but it's more of a rarity. And actually, on average, we get one solar eclipse somewhere about every 18 months or so. But if you stand in the same place, like here, then you have to wait on average about 400 years for another one to come round. It varies quite a lot, but that's roughly what it works out at. And they come in pairs as well. It just so happens that when the moon is lined up properly with the sun on this side, then 14 days later it will also move into the Earth's shadow here, and you get a lunar eclipse. And it so happens that there's a very deep partial lunar eclipse on the 4th of April, following the totality on Friday. But we won't get to see that either, because it always happens that if you see a total solar eclipse on one side of the Earth, the lunar eclipse that goes with it will be seen from the other side of the Earth. To see a lunar eclipse, it's relatively easy. You have to be on the right half of the Earth, i.e. one where it's night time when it happens. There is a thing, and we'll see a little bit of the effect of this shortly, but there are several cycles called Saros cycles running at any one time, and I'm not going to go into the detail of that, but just to say that each one is 18 years, 10 days and 8 hours long. And the 8 hours is extremely important because it has an effect on where you have to be to see the eclipses, and we'll have a look at that just there. This is just a representation of the various types of solar eclipse, and this is a total solar eclipse here where the moon's shadow does actually reach the Earth. in a very small area, usually only sort of 100 miles wide or even less. You can have then an annular solar eclipse, which is this one here, where the moon's shadow does not reach the Earth because the moon is too far away to actually cover the entire sun. And looked at from the Earth, that's the one where you see the ring of sunlight around the moon's shadow. There is a thing, a curious one and quite rare called the hybrid solar eclipse, and that's where the moon's shadow can touch the Earth in some part but not quite reach it in another. And you get an eclipse that is that along its track, because there's always a path to these things, is partly annular, partly total. And the total bit will always be very short. And that was taken, that's a picture there of the 1999 eclipse, the last major eclipse that we had visible here. But that was taken from the Mir space station, and you can actually see that that is the shadow of the moon on the Earth there. So that's what it's all about. So in terms of where you have to be to actually see a total eclipse, here's a map of the eclipse tracks from all of those between 1997 and 2035. And the one that concerns us this week is this one here, 20th of March 2015. It's a very strange eclipse track because it starts in the middle of the Atlantic there, heads sort of northeastwards, making landfall in only two places, the Faroe Islands to the north of us there, and also Svalbard, which is this part of Norway just up here. So really not many people are going to see the totality here, even in terms of those who actually live there. But because we're quite close to this, we do get a very deep partial eclipse. Well, let's talk about some of these. The 1999 eclipse, which was the last big partial here, that was the eclipse track here, and it went through, didn't touch Ireland at all, but went through Cornwall, where it brought very dark weather with it, as I remember, and then passed right across through France and Germany and down through Turkey and right off through into India. And now let me just explain something rather. I mentioned there the Saros cycle. See this how this track here has a certain shape to it. And if we look at that, and then we sort of, it was 18 years, 10 days, and 8 hours later. The important thing about the 8 hours there is that the Earth rotates 120 degrees in 8 hours, and so when that cycle comes round again, here it is, 21st of August 2017, it goes right across America. And we'll talk more about that eclipse coming up there. But you see how that is the same shape as that. And there's some other totalities, I'll look at those later on, but that's the general idea of that. That's a very good photograph of a total solar eclipse. In fact, it's several photographs that have been taken at different exposures and stacked together. And that was actually taken at the eclipse in 2010, which was total in Easter Island, in the middle of the Pacific. And what the photographer has done is he's taken lots of pictures at different exposures, so that the huge range of light that there is, the inner corona there and the outer coronal bit here, he's captured all of those, and it's got huge structure in the shape of the corona there, and he's taken a very long exposure here and even actually got features on the moon, the unilluminated side of the moon, and that what you're seeing there is the moon being illuminated by reflective Earth light. So that's, you can see there's sort of craters and stuff there. So that's what a total solar eclipse looks like. It only lasts a couple of minutes or so, maximum about 6 minutes in theory. Here's a movie, and this is a bit where we keep the fingers crossed because actually making this work is a bit hit and miss. That should run. Here we go. Yeah, this was a movie made by a guy called Colin Legg in Australia in 2012, and he's actually filmed the shadow of the moon coming across the Earth. And we can look at that again in a slower motion. This is a time lapse where you're looking at about 2 minutes of shadow time here. So there you are. And you see the sun's atmosphere because the moon is completely covering the bright part of the sun. And this shadow here, see over here is not in the shadow, but where we are is, and then that comes out again there. So that was Australia 2012. They've got a couple of views of that. And it gives you a huge idea. I've got a photograph that I took in a similar eclipse also in Australia, which is the last slide in this presentation actually, but it looks like that. So we'll watch this through. One of the things I have, until fairly recently, I'd never seen it conveyed at all on television or anything what being in a total solar eclipse is like. And then I actually watched a program that came on, which was a Horizon special, about 18 months ago. It was called The Secret Life of the Sun. And what they did there was they took TV presenter Kate Humble, who had never actually seen a total solar eclipse at all in her life. They took her to Australia, that same eclipse, Australia 2012 in Queensland, and they just put her in front of a TV camera. And what actually happened next, I think, was quite stunning, because my personal first total solar eclipse took place on a beach in South Australia in December 2002. I actually travelled to a place called Ceduna, and Ceduna is, I can only describe it as being 500 miles from Adelaide, 800 miles from Perth, and not near anywhere else. So I made a big holiday out of it with a couple of friends of mine. And I spent 3 weeks travelling around Australia, mostly by car, and I actually did a round trip of 25,000 miles to go and see something that lasted 32 seconds. Unfortunately, the weather on that day was okay. It was actually a bit 50-50 for a while, but we did actually see the totality. People down the far end of the beach from me, they did not see the totality. There was one cloud on the way, and that can happen.
Wow, that's incredible. The sun has just made an appearance above the clouds, and it's got a chunk out of the top left corner.
The moon has begun to block the sun, but the sun is so bright that we won't notice any darkening of the daylight until it's almost completely covered.
What do you think, Francisco? It's looking quite skinny now.
It's quite skinny, yes, about 10 minutes before totality.
Yeah.
So this is where things are going to happen faster and faster. The darkness is going to really come much quicker.
You feel it. It's physical. And it's sort of terrifying, actually. Isn't it?
It is.
I mean, just, look at it, it's just, every moment you can feel the light just dropping and dropping. It's like somebody's stealing the sun. And it's now just a tiny hair's breadth in the sky.
Yeah, we've had 2 minutes, 2 minutes,
2 minutes.
to go.
And it's so cold. The temperature's just completely dropped. It's like everyone's collectively holding their breath. Oh my goodness.
Oh, that is
It's the most amazing thing. I can't believe how beautiful it is.
The moon has completely blocked the disk of the sun. A delicate halo is all that remains. It's the corona. Francisco now has 2 minutes and 2 seconds to get the photos he needs.
Here it comes. It's ridiculous.
Isn't that amazing? Amazing.
It was worth getting up at 2 o'clock in the morning.
Absolutely.
Absolutely worth getting up at 2 o'clock in the morning.
I challenge anyone to watch a total eclipse without being deeply moved. It's a...
There you go, Kate Humble. I do implore anyone to go and see a total eclipse if you get the chance. But we're not going to see that here. Just for completion, this is what an annular eclipse looks like. I have never seen one. I was going to go and see one, well, I did go and see one, but what I actually saw instead was fog on the Moray Firth. There we are. It was one a few years ago. That was 2003 in Scotland that we went to see that. Now then, so never mind all that totality thing. We're not going to see that here because we're not in the right place. So we'll talk about a little bit about what we're going to see on Friday. And actually, I wouldn't be surprised if we did see something very much like that. And that is a real photograph that I took actually in China in 2009. And that was taken just a few minutes before the totality there, which I did not see. Because there was all this cloud here. I would absolutely, of course, advise anyone not to take a photograph like that ever, because I did not use any filter on that, other than that thoughtfully provided by Mother Nature. So, what's going to happen on Friday is that we are some way off the total eclipse track, and we're in a place where, depending on exactly where you are in the province, somewhere between 93 and 95% of the sun will be obscured. And this is not total, you don't get that lovely total experience that we witnessed from Australia there. Here's where the eclipse track passes through the North Atlantic, and the times here, it's coming in at maximum at 9:15, 9:30 there, 9:45, and where Terry and Kate are, is Torshaven and the Faroe Islands there, and the only other landfall on that is above the top of the map there at Svalbard, north of Norway. We here, in all these places not very far off, then we get a deep partial eclipse. And as I say, we get around about 93% in Belfast, about 94.5% on the north coast, a little bit more still if you go to Donegal. The only thing that could possibly go wrong, why you wouldn't see that, would be the weather. I'll give you this is a computer simulation of how it will look, and this is starting at about 8:15 in the morning, and about 24 minutes past you get the first little chink of the sun there. If you're looking through specially filtered apparatus, you'll see that there's a dent in the sun at about 8:30 or so, and then more and more of the sun is progressively covered until we get to the point where, because the moon is actually obscuring the top part of the sun, this crescent comes around and we get a nice sort of smiley face view of the sun there. But unfortunately that sliver of sun never goes away and starts coming around the other side. Then the moon moves further across the sun, and by about 20 to 11 it's all over. Normality is restored until 2026 here. So that's how it will look, weather permitting. Just go through those timings. The first contact, as we call it, partial eclipse begin. The first contact in Belfast will be at 8:26 a.m. The direction of the sun here, 115 degrees, so that's just a little bit south of east. Altitude 16.3 degrees, so quite low in the sky. Just a bit off east. 16.3 degrees is roughly, if you hold a fist out to arm's length like that, that's 10 degrees. So if you put your fist there on the horizon, that's 10 degrees there. So 1.5 fists worth is more or less what the height in the sky you're looking at. It is actually surprising how high that is when you look at it. It's enough to certainly see above hills and stuff. You don't need a flat horizon or anything to see that. But an hour later, it takes an hour to sort of cover the whole sun. Just as an interesting rule of thumb, it is something that comes up a lot when you start looking at occultations and eclipses and stuff. The moon moves its own diameter in an hour. That's just a convenient thing to remember. So here, this is the moon moving. It touches the sun there at 8:26. At 9:31, it's covering as much of the sun as it's going to. So that 93% or so. And then that eclipse ends 10:39 when it's moved the other sort of hour's worth there, and it's all over. And through here you're just moving through south of east. 130 degrees is southeast, by which time the sun's altitude is 24 degrees, quite high up in the sky. I'm personally taking a a viewing point that is across water, and 24 degrees is low enough to actually put a glitter path on water. So we will see that, and I'll talk more about that when we do photography. But that's the timings of the eclipse. So here's the important thing, and I've written this in red just to try and underline these things. You know that 6 or 7% of the sun remaining is still just as lethal as looking at direct sunlight, because that's what it is. And this being a partial eclipse, there is not any part of it where it is safe to take off your eclipse glasses or use unfiltered equipment or anything like that, because it is full-on sunlight. And just to put this in astronomical terms, you know how bright stars are magnitude, first magnitude and so on. A full moon is magnitude -12, and the sun is magnitude -26.7. Well, when most of it is covered, it's only -23.7. So you're still looking at something extremely bright there that you cannot look at directly. So we have some eclipse glasses. We didn't probably have as many as we'd like, but we have some that go to all of our observing locations and try and keep people safe. Do pass them round and share them, because that's what we need to do. There are some other things that I can say, yeah, they work. Welder's glass. Number 14 at Welder's glass, accept no lower numbers than number 14 if you're going to look through it. But that does actually filter out all the things you need to have filtered out. Things that do not work, that people sometimes say are safe for viewing. CDs, DVDs, film, smoked glass, photographic filters, none of that is of any good whatsoever for looking through, because although they might look dark, they probably absorb quite a lot of light. What they don't absorb is heat. And the infrared goes straight through, and because your eyes are designed for looking at light, they do not have any sensors for heating. So burning your retina causes you no pain, in fact. It's just done very quickly, very easily, but unfortunately it's very permanent. And so it just keep safe, use only the proper things. What else can we do? There's filters you can put on telescopes. Now, one thing that Andy has been selling guys quite a lot is barder film, and barder film does contain all the right materials to filter out not only the correct amount of light, but also the radiation and the heat, infrared and ultraviolet and stuff. When you sort of make these, here's one I made earlier. So this is not aluminium foil. It might look like it, but it absolutely isn't. You do have to check it for the edges. See, I've just put an extra bit of tape around there to seal that, and check that the material. Actually, I've decided not to use that one. It's got a little hole in it, but just check. Hold it up to sunlight and actually see if you can see any light coming through. Other than that should come through, and if you can, then it's not safe for use. And absolutely do not ever put a filter that's on the back end of a telescope. You have to filter the front element of a telescope. And I will tell you a story at my own expense here. That the 1999 eclipse, I didn't know much about all this, and I was young and stupid and all that. But I knew a dangerous amount, if you know what I mean. And I had a 75 to 300 telephoto lens, and I thought I'd like a picture of the partially eclipsed sun, because I saw a 97% eclipse then. I didn't go to a place where it was total. So what I did, I got my camera, and I didn't have any barder film or anything like that. I didn't know it existed, but I did have a couple of pairs of eclipse glasses. And eclipse glasses are a certain size, and didn't cover the front element of my 75 to 300 zoom lens. So what I thought I'd do, being a little bit clever, dangerously clever, was I actually cut one to shape and stuck it to the inside of the back of my zoom lens. And then I sort of went up to watch the eclipse, and thought I'd take a test shot of the sun. It was a gorgeous day where I was. It wasn't where the eclipse was total, but it was a gorgeous day where I was, and I got my camera with my zoom lens and my improvised filter on the back of the lens, held it up to the sun, just got ready to take a test exposure, and through the viewfinder I actually witnessed a fire taking place inside my camera. Now, fortunately, I was quick enough in getting it out of the way, and I still have sight in both eyes as a result. But that was a close one, and I'm quite happy to share that with anyone if it saves one eye, A more safe way of doing things comes with a few caveats. But here's me projecting the sun onto an improvised portable screen with and that is probably most of you guys have even got one of these. That's the Skylark scope that the German supermarket sells every Christmas, and it is very good at doing this job as it happens. There's no filter on that. I have just improvised a shield there to create a shadow that's the same size as the screen here. And I've used the 20mm eyepiece to actually project that. So you've got a 700mm focal length scope and a 20mm thing on there. It gives you a lovely image actually, and there is a very visible sunspot in that image there when you get it focused up. Slight caveats with this. I have actually put that deliberately low down and pointed downwards, so that no one more than 1'6" could inadvertently go and put their eye to that eyepiece there, because that would be fatal. There is a slight issue with my cat here. She's fabulously curious about anything I do. Things like that. She has to be involved. It's fabulous. Don't do that with bigger scopes. It's fine with that 70mm refractor, because the amount of heat that you collect isn't necessarily too much to cause a problem. You start doing that with bigger refractors, you actually collect a lot of heat that ends up in the eyepiece. And whilst the eyepiece is glass and most of it goes through okay, there is a certain amount of absorption must go on there, and if you do that with a bigger scope, you run into problems. And it's best done with a refractor. The refractor is the simplest sort of scope for doing this. If you did that with a Newtonian reflector, then if you actually think that the cone of light is getting denser all the time, you are focusing a lot of heat onto the secondary mirror. And the secondary mirror is held where it is by glue, which might melt, and then drop your secondary mirror down onto your primary. And whilst that's not necessarily dangerous from an eyesight point of view, it damages your wealth. So best done with a small refractor, that projection. Right, where are we up to? Other things you can do. There's all sorts of optical effects that you can see during a partial eclipse that are just as much fun. This implement here is not just useful for straining spaghetti, although it's very good at that. This is actually just a kitchen colander. If you hold that there, then what happens is that the sun's shadow, which is normally round, does actually show the crescent. Each hole in the colander acts as a small lens and creates a crescent image there. That's a nice one to do. You can, on that same sort of theme, there's several different ways of going about it. You can do it with your hands if you want. You've got a nice wall there. You see that's just people holding their fingers together, and the crescent of the partially eclipsed sun appearing on the wall. And a few things just about eclipse. Like this is a photo I took at that first totality I went to in Australia. One thing about the light, the light is actually at that point quite dim for a start. We're probably about a minute away from totality at that point, but that's not dissimilar to how the sun will be here on Friday morning. And if you look at the shadows here, the shadows are really, really harsh. Here's my video camera, and you can see fantastic detail in its shadow. And the reason being there that the sun, as most of it gets blocked out, approximates more to a point source of light. And it is the fact that the sun is a visibly identifiable size is why it creates slightly diffuse shadows. And in this situation it does not. It produces very harsh shadows. And that's something to look out for. And there again, that's the same place. That is the Ceduna Motel in South Australia. It's called the Ceduna Motel because it's the only one in Ceduna. here you can see where light's shining through the trees. You get all these crescent-shaped shadows, and that's. I think that was actually taken. I think that was taken somewhat after the totality, in fact. So that's different types of light you can look out for. You may be able to see one or two planets. This is how the sky is at that time. This is 9:31 on Friday morning, and here's the sun, largely eclipsed by the moon. I think you probably will, if it's clear, be able to see Venus. I don't think you'll see Mars. You definitely won't see Uranus. And you may be able to see Mercury. You'll notice that these planets are quite close to the sun, and what I would recommend, if you're going to go hunting for them with binoculars, which is the best way to find them, that what you do is you do it from the side of a building, such that you've got a house between you and the sun, so that you can't inadvertently point your binoculars at the sun while you're looking around for Venus. So that's a possibility. I think if we do get clear sky, that's one thing we might be able to see there. We will, of course, want to take pictures, and here's my two setups, really. This is a bar film film. I've got the lens and camera here. Actually, you want to come and have a look at it afterwards. But that's just that's a 400mm lens, a very ancient age. I've paid about 30 quid for it. It was made in the 1970s, and it does absolutely, one job very well. It is a nice camera for looking at the sun and moon with. And I put that on a micro 4/3 camera, so I actually get a bit more magnification than you would with other cameras. But Barber film covered, and not only Barber film covered, but actually that's a nice tight fit on there, so it won't blow away, which is very important. Don't want filters falling off. This here, I would probably be advising you probably not to do this, but it does work. Eclipse glasses through a sort of compact zoom camera of a reasonable length of lens, and this one here is a Panasonic that has a 400mm equivalent lens. That will show actually quite nice detail in the sun. I've photographed sunspots like that through the Eclipse glasses. And if you look at this carefully, Jude took this picture today just to illustrate the point. I am not looking at the sun. I have used the camera to shade me from looking at the sun, and actually I'm looking at the screen on the back of the camera, and my eyes are not exposed to sunlight at that point. And you do have to be very important about that. That little camera, actually I have damaged that camera slightly. It has a little spot on it, but I've been taking pictures of the sun with it. But not to be noticed, to be honest. But so there's two ways of taking pictures. One that I haven't actually covered. If you do have a filtered telescope, with an eyepiece on it, I will be taking one down to my location. Actually, a phone to the eyepiece can get quite a nice picture of the sun through that. Certainly you'll get a nice crescent shape quite easily. Phones ubiquitous now, everyone's got one, and they've all got a camera in, pretty much. Other things that you might notice during the sort of deep partial part of the eclipse, it may get a little bit colder. In fact, if you wanted to do a little experiment, take a thermometer and just take periodic readings for it. You find that that the temperature starts off coldest just before sunrise, and then gets warmer and warmer and warmer, and you might find that after about 8:30 it starts to drop down a little bit. Probably will drop 3 or 4 degrees as a result of the sun being obscured. More so if it's clear, less so if it's cloudy. Cloudy keeps the heat in, but you will notice that it gets a bit darker. Animals and birds can get agitated by the change in the light. They start to feel that nighttime is coming along prematurely, and they get quite excitable. It affects your vision in a fairly curious way. As I explained, I'm probably quite unusual in that I've been to a 97% partial eclipse, and most astronomers would say, well, why didn't you go for the 100? And there's all sorts of reasons for that. But I have experienced that, and as the light gets darker and darker, it does so at such a speed that you don't really kind of realise, because your iris has time to adapt to the gradually darkening light. But one perception that you do get is that your colour vision becomes not so good. It's like you've turned the saturation down, because the way in which your eye is dealing with the light is such that the colour isn't really getting much of a look in. It's like when I was out photographing the aurora last night, I saw the fabulous colours that came out of that. I was vaguely aware of a bit of green in that, but because low levels of light, the eye doesn't actually discern colour at all. The cones are not really as sensitive to it. So it is a strange experience, but one thing that you can tell, if you actually have an SLR camera or something and you just look at the same scene and see what your camera exposure is, you'll see that it does drop throughout the course of the sun being covered up. So that's things to see there. Let's go through where our viewing sites are. This is just a Google picture actually of down where I'll be in Larne. I'm going to sort of set up sort of at the end here. There's some seats and a bit of concrete thing there, and there's loads of parking on the Chamber Memorial Road. There, that's down by the seafront at Larne, and we do have that view across water. The sun will be sort of somewhere over there, and when we come to taking pictures, what I want to get, I explained about there will be a glitter path, i.e. the sun will shine off the ripples of water, and each of those little ripples will contain its own tiny crescent at the time that the sun is obscured. So I want to actually sort of point a lens into that and see how it looks. That's the Larne one. We've got, if you go to the website, there are Google Map links to the various locations. Scrabo, we went to, I think we went to attempt to see a different sort of eclipse from Scrabo once, but top of the hill, there's a huge car park there, and we've got loads of space there. And David Collins and George Brannan will be manning scopes up there for people to have a look at. And again, there's a great view in the direction we're looking at, sort of towards the southeast, across Strangford Loch there. Brian will be up in Port Ballantrae. Again, we've been up there before, and that's it. Again, there's loads of space in the car park, both for car parking and a couple of telescopes and stuff there to look at the sun. And of course, the main event is out the front here at Queen's. We all know where that is because it's just out the door here. And I think we're going to sort of set up somewhere along. You can see the whole of the eclipse sequence above the physics department where we are now. From that location, so that's where the 4 locations on Friday will be. This is the question that after any eclipse everybody always asks: when is the next one? Well, there's quite a few possibilities here, and there's this is where we are now, March 2015, this eclipse here. The next big total eclipse, and I'm going to go and try and get to it if I possibly can, is this one here on the 21st of August 2017. It runs right across the United States, from Oregon here right over to South Carolina. And the great thing about the United States is that you can go there and you can hire a car and you can go wherever you want, and if the weather forecast, the day before the eclipse says that you're in the wrong place, you can be 500 miles away on their road network by the next day. So you can do that. Where I went on a trip to China, this eclipse here, I've been in that one. In fact, I've been in this one here, there, that one there in Turkey, and that one there in China. And the thing with China was, you are where you are, and you can't wander around. Your tour is registered with the government, and that's where you have to go. So there's no opportunity to look at a bad weather forecast and say, I don't want to be here. In the United States, you can do that. You can get about the place very easily. The next big partial eclipse here is this one here, 12th of August 2026. But what you really want to be doing there, probably because it's quite accessible, get yourself to northern Spain, here where that's total. total eclipse there. There's 2 eclipses in a year in Spain, because this one here, 2nd of August 2027, that is total in Gibraltar, Malaga, and that southern Spanish coast, and also right across North Africa. Yeah, so that's probably a good one to try and get to. And my favourite one that I think I'd like to, well, there's two favourite ones here that I'd like to get to because of the location where they are. Because you always want to build a holiday around these trips, because you don't want to go to the other side of the world just to see an eclipse, but actually it's a good reason to build a holiday there. This one here, 8th of April 2024, one of the places that's actually right on the line of totality there is Niagara Falls, which I thought would be a nice place to see an eclipse from. It also comes up through Texas and across a lot of America. But Niagara Falls, I think, is good. This one here, it's 22nd of July 2028, right there, goes right through the middle of Sydney. So for 4 million people who live in Sydney, they don't have to go anywhere, they just get an eclipse. It's fabulous. So there we are, that's that much. There, I think that's those I've explained. There's another one here, if you want to see a total eclipse in Ireland, there is one right on the southwest tip of Ireland, not here, on the 23rd of September 2019. If I'm there, I'll be astonished. But I will make the effort if I'm still, that's that American eclipse. I don't know where I'm going to go on this. This you can pick a place on that line of Oregon down to South Carolina, and for me, that's all about the weather. You have to get yourself somewhere there where it's not cloudy, it favours the northwest. The southeast is more likely to be cloudy in August than the northwest. I'm thinking Idaho Falls, which is about there, and that's Yellowstone National Park there, so that's maybe where I would go. One other different sort of eclipse. We have another eclipse this year, which we can see. And on the 28th of September, which sounds great, at between 3 and 4 in the morning, which is not so great. That's the night of my birthday, and I think I might stay up late night that night and watch the total lunar eclipse there. The total lunar eclipse is unlike solar eclipses. You don't have to go anywhere, particularly you just have to be on the right half of the Earth, i.e. the bit where it's nighttime, because then you're looking out at the moon that actually then does pass through the Earth's shadow and takes, I mentioned earlier that the moon moves its own width in an hour, and actually it's doing exactly that here. From 3:13 to 4:22 is the time that it actually moves right through the Earth's shadow. And that's a very beautiful sight because it doesn't go dark, it goes darker, and it goes this deep red colour because that's sunlight being refracted through the atmosphere of the Earth. And how much darker it gets depends on a couple of things. One is how close to the centre of the shadow it gets. And this one here, I took this in March 2007, and this is quite near the edge of the shadow here, so it's lighter, and the rest of this is darker. It also depends hugely on the state of the Earth's atmosphere at the time, and that varies depending on whether there's been stuff like volcanoes or a lot of air pollution and so on. And sometimes that can be a very deep red, and sometimes it can be quite a light red. This one was somewhere in between. This was down the middle. I mean, you can't really tell because I've exposed the photo correctly, but so it would probably look like that, whatever it was. But that's well worth seeing. And then, as with everything else, the only thing that can go wrong is the weather. I've certainly missed a couple of lunar eclipses because of the weather. So that really is all I have to say about eclipses. That is the picture I told you about there. That was the totality I witnessed in Sedona in December 2002. I wasn't going to take any photographs, I was just going to watch the eclipse and experience it, but I'm standing in front of the total eclipse with an SLR around the neck, so what do you do? I quickly snapped that, and it came out far better than I imagined, because that was a very short eclipse there, 32-second totality, which means that the actual width of the shadow wasn't much, and you can see the daylight either side of it here. These places were not in an eclipse. I saw this exactly like that. People at the far end of the same beach as me did not, because of that cloud. So there we are. That's all I have to say. Thank you very much.